question 4 asks us to sketch this graph here and find all the coordinates of the axial intercepts, that means x and y intercepts, and turning points. So generally what we'll do is we'll actually find these axial intercepts and turning points first and use them as a guide for sketching the curve. So let's do that. So how do we find the axial intercepts? Well, let's find the x-intercepts first. What can we say? Y equals to 0. So at the x-intercept y equals to 0, so we can say 0 is equal to x to the power of 4 minus 4x cubed plus 5x squared. We can simplify this to be 0 is equal to x squared, and then on the inside we have x squared minus 4x plus 5. Now, this one, the x squared here, this gives us solution x equals to 0. So we know x equals to 0 is a possible solution. What about this set of answers? What can we get from that? Well, actually, if you test the discriminant, b squared take 4ac, what is this? B is negative 4, so b squared is 16 minus 4 times 1 times 5. This is actually equal to negative 4, which in particular is less than 0. So that means this set of solutions, this part of it, this factor, has no real roots. So it's never going to contribute towards equaling 0. So the only x-intercept this has is x equals to 0. So let's find the y coordinate. When x equals to 0, what do? X equals to 0, we substitute 0 in here. I can see every term has an x in it, so I know x equals to 0 implies y equals to 0. So my point is 0, 0. And actually, for my y-intercept, I was going to substitute in x equals to 0 anyway. So this is actually the only axial intercept that I have. It's both the x-intercept and the y-intercept. So what about turning points now? How are we going to find out about our turning points? Well, what do we know about a turning point? At a turning point, dy by dx equals to 0. So what is dy by dx? Well, differentiate this and we get 4x cubed, take 12x squared plus 5x squared. Plus, what am I talking about? Let's undo that. Oh, redo that one. No, not quite so much. Okay, sorry. Differentiate, we get 4x cubed minus 12x squared plus 10x. And we set this equal to 0. What does that give us? Again, an x factors out. In fact, we can factor out 2x this time. And we get 2x squared minus 6x plus 5. So again, what do we have? This one tells us that it's possible that x equals to 0. This is one possible solution. Alright? What about this one? Well, again, we test the discriminant. And what do we find? Well, b squared take 4ac, which is our discriminant, is equal to 36, take away 4 by 5 by 2. So this is actually 40. So again, it's negative 4, which is less than 0. So therefore, this one has no real roots. And in particular, will never equal to 0. So our only turning point then is when x equals to 0, and we know already when x equals to 0, y equals to 0, we've got this point 0, 0. So is this a maximum or a minimum? We would still need to test that. And what do we find? We find, well, we can do this in two ways. We can do a second derivative test, which I believe you guys covered in secondary 4. So d squared y dx squared is actually equal to 12x squared minus 24x plus 10, and then you just substitute in x equals to 0 from here, and you find that d squared y over dx squared at x equals to 0 is equal to 10. So it's positive, so this is going to be a minimum. The other way to do this is, of course, the first derivative test. Since this has no real roots, this means this thing here, this is going to be strictly greater than 0, no matter what x value I put in. So, if I have my point here, this is 0, and I look at 0 minus and 0 plus, well, and I've put my point up here somewhere, so this is my point 0, 0. Well, what's happening? When we're slightly less than 0, then when x is slightly less than 0, then 2x is slightly less than 0. This whole thing is positive, so a negative times a positive will be negative. So my gradient will be negative, which means it's going down. Here at 0 it's going to be flat. Then what about after 0? When x is slightly positive, then 2x is positive. This is always positive, means my gradient also will be positive. So I can say this point here will be a minimum. So two ways to figure out the same thing. Now, at this stage, some of you may be tempted to just rush on ahead and say, okay, well, I know what this looks like. This is going to look something x, y. This is going to look something like this. It's going to look like a U-shaped curve. And you would be wrong. This is not, this answer is not correct. Right? In fact, if you look at this, we should be a little bit surprised. This is a x to the power of 4 graph, right? We would expect these to have a lot more turning points and a lot more intercepts and a lot more detail than a simple quadratic. So what are we going to do? We're going to use our graphing calculator. And we're going to look at what this looks like. So I'm going to just key in y is equal to x to the power of 4 minus 4 times x to the power of 3 plus 5 times x to the power of 2. What do I get? Well, would you look at this? This isn't at all what we expected because of this part of the curve here. There's a funny little wobble. In fact, what's happening here is you're seeing two non-stationary points of inflections here and here, where the curvature changes, and this is our d squared y over dx squared value changing. So if we were to look at what the graph should actually look like, if we were to sketch it very, very quickly, you should have your axes. They should be labeled y, x. You should clearly mark your point here, that this is 0, 0. On the left hand side of the curve, this should increase smoothly as we expected to see, and you can see that that's what's happening over here as well. But on the right hand side, it's going to give me a little wobble, but not just any wobble, right? It's going to give me a very specific one where it goes up like this, and then down, and then up again the way it was before. So this very, very unique shape where it goes up and then down and then up again. Yep, and that's because of the change in the second derivative, where it's going from being positive to negative. So this is roughly what your curve should look like, and of course you will have labelled it y equals to x to the power of 4 minus 4x cubed plus 5x squared. And now we are done for question 4.